You've spent all of your money upgrading your Wi Fi gear, but for some reason, things don't seem to be going faster. It doesn't matter if it's at your house or at your office, the numbers just aren't adding up. In this episode of the Tech Field Day podcast, is Wi Fi fast enough? Welcome to the Tech Field Day podcast, where we bring together a group of influential IT experts from across the industry to discuss a single idea about key concepts. This podcast features a variety of perspectives from members of our Tech Field Day delegate community, and we often record it in association with one of our events, in this case, our upcoming Mobility Field Day. Tech Field Day is a part of the Futurum group, and this podcast is also published on our sister site at TechStrong TV. In this episode, we're going to be talking about Wi-Fi. But before we get to that, I'd like to take a moment for our guests to introduce themselves, starting with Keith.
Oh, hey, name's Keith Parsons. I produced the WPC conference, the Wireless and Professionals Conference, as well. I've been doing Wi-Fi for more than 2 decades. So this is going to be fun.
Hey, I'm Rocky Gregory. I'm principal architect at Evotech. Previous to that, I was global director of wireless for Nike.
Thank you, Tom. I'm Ron Westfall, research director here for communication networks at the Futurum Group.
All right. Well, thank you all very much for joining us. Let's jump into the premise for today's episode. No doubt you've gone into a store recently and been overwhelmed by the amount of choices that you have when it comes to Wi-Fi hardware. Sure, the Wi-Fi Alliance has simplified it by adding numbers like 6, 6E, and 7, but what you're really interested in is the other numbers on the back of the box, the throughput numbers. Is this going to be the magic device that allows me to stream my movies even faster? Is this going to be the thing that allows me to download those files off of the internet even quicker than I possibly could have? Well, the answer is probably not, because as it turns out, Wi-Fi is fast enough. All right, before you start a flame war in the comments, because I've actually been involved in one of those before when I said that the new radio in the MacBook M1 was fast enough compared to the radio in the previous generation, even though there was only 100 megabits per second difference in the two. I think we need to kind of start off by letting people know that, the Wi-Fi speed that you see on the back of the box isn't exactly the Wi-Fi speed that you're going to get from the access point. I'm going to leave it to my experts out there to maybe explain to our audience real quickly, why is there a disconnect between those two numbers, the perceived throughput versus the actual throughput?
I'll start. That's a pretty easy one because marketing is the actual answer. Marketing likes to show really big numbers, and the numbers they use are not throughput. They're what's going on at the phi layer, the physical layer. So the bits are actually going fast, but a whole lot of the bits have nothing to do with carrying your payload. So Wi-Fi has the 802.11 protocol has a lot of overhead built in. So you'd be lucky to get half of what the bit traffic is actual payload. So that's one. Two, when they are marketing those, they take the best possible technique that could be used with that version, say Wi-Fi 7, with 8 spatial streams. Well, clients don't have 8 spatial streams. So your device will never reach the level that the AP has on its box. So they're good marketing numbers, but in reality, you'll never hit those numbers. So that you shouldn't be looking at those numbers. You should be looking at what does your application actually need. And for this one, I'd like to just go back to a simple one. The lowest, slowest possible Wi-Fi today is 6 megabits. And that's terrible. That's MCS 0. It's the worst Wi-Fi you can have, and it's 6 meg, which is more than you need to send a YouTube video at 4K. So one user watching one Netflix can work with the worst possible Wi-Fi. So it's not really about throughput.
I agree with Keith, and I don't think it's unique to the Wi-Fi industry. I mean, marketing is out there across the entire industry. So we can certainly look at, the routing switching vendors doing the same kind of thing, et cetera. And what I think is important here is, okay, what is the Wi-Fi industry doing to, enhance what is realistically possible in terms of throughput speeds, regardless in the environment, whether it's enterprise, consumer, new deployment, a brownfield deployment, et cetera. And one thing I want to shine a spotlight on is a couple of key takeaways that I saw from the Wi-Fi World Congress that was just completed out there in Mountain View. And I think what's interesting is I've been having these conversations, and many of them are Wi-Fi centric, but some of them are like, let's look at the network overall and what's needed. And yes, I'm going to interject AI here because I think it will have a positive impact on what's needed, and that is improving really the quality of experience for a Wi-Fi implementation, at home, within the enterprise, and this includes players such as Qualcomm, MediaTek, as well as AirTies. And what they're looking at is that because Wi-Fi is integral, it's an essential connectivity technology for any experience. That is, the AI capabilities can actually improve what's going on at the edge. That is implementing AI at the edge, bringing AI to where the data is, if you will. And as such, what I think is going to happen is we're going to see AI become an ally for improving Wi-Fi performance as well as quality of experience. And that includes reducing the latency more, just having more intelligence at the edge to, optimize what's going on out there amongst the access points, but also what's going on at the backhaul and the overall network. That is, having more visibility, awareness, and intelligence as to what's going on, not just with the Wi-Fi portion of the network, but the overall network. Now, that's simpler within, you say, home environments, but the same principles apply. And so I think that's something that's important, that this was getting, I would say, a lot of not just technical emphasis, but also, again, that marketing emphasis. And so this is going to help the CSPs out there become, I would say, more proactive at being able to troubleshoot an issue with a Wi-Fi implementation, or telling the customer, hey, it's not your Wi-Fi, it's something else. It's your browser, it's your PC, and so forth. But just having more rapid turnaround and being able to do that, and having just that more capabilities at hand to solve the problem at hand when it comes to performance.
I think the other piece is that's an unloaded network that they're talking about when they put the number on the back of the box. And especially in the enterprise, when you're serving 50,000 clients on a campus, they aren't all going to get that connection that they had at home. And so there's the expectation setting. And in a lot of enterprises, the critical app has become speedtest.net, right? So it's the person sits down at their desk, their app is slow, they hit speedtest.net, and the phone rings at the help desk. The Wi-Fi sucks, right? So to Ron's point, there are so many pieces in between the user and Google and the user and Facebook, whatever they're going to. But in the end user's view, it's always the Wi-Fi because it's the unknown, right? It's what they see ultimately as their entire connection. So I think there's the visibility throughout the network, to Ron's point, is absolutely critical. It's very critical within the enterprise where, again, there's this perception that if it's not as fast as it is at home, it sucks, right?
And just to follow on what you're saying, they hit speedtest.net or something like that, fast.com, whatever, to say, "See, it's not what's the number that they're after?" And I had my ISP to my house came by and he's like, "What are you complaining for?" And I'm said, "It's not that I'm not getting I can get 300, 400, 500 some days. It's other times when traffic on my street is being shared, speedtest.net, they're hosting their own server. It's their upstream internet that's slow, and when you explain all of the parts to them, "Well, yeah, but you got this big number." It's not about the big number. It's kinda like doing Wi-Fi surveys and say, "Hey, it's all green." Yeah, that doesn't matter. Just because you had a signal doesn't mean your Wi-Fi's good. So, there's a lot of things we can do in a troubleshooting sense. One of the things that's a good good answer to this premise we're talking about is how do you measure that quality of experience from the client side? And vendors have been thinking about this for a long time, and they've realized there's a whole bunch of different parts. The Wi-Fi is just like the last mile. It's from the access point to your client device, but the entire network is being judged from the consumer's standpoint. So we need to have our tools that can look at the Wi-Fi portion, client to AP, and then the AP through the switch fabric over to the WAN link and then out to whatever the apps are. We need to be able to see all those parts. And one of the things that Ron was talking about bringing AI in is a lot of the vendors are now using AI to look at that really rich set of data they have collected from how long did DHCP take? How long did it take for a DNS query to come back? Where is the latency in all those little hops? And is it affecting an entire building or everyone off of one switch or off of one WAN link? And be able to help identify those problems sooner by looking at that huge set of data that they're collecting.
Oh, sure. No problem, Rock. I'll just make a quick observation here. I think to Keith's point and your point earlier, Rocky, about, a network wide intelligence is that I think it's fueling the campus network as a service or NAS use case. And I think that was another important takeaway from the recent Congress. And that I think is being accelerated by players like Nile that have demonstrated, with demos like at Leap 2025, that they can support up to 2 million square feet, and also show, an implementation of a zero trust security implementation, along with the other, built-in benefits such as rapid deployment and having just that network-wide awareness. And I think this is going to help, with the competitive mix that is, help enterprises with campus or any organization with a campus requirement just have more options out there. And yes, folks like Cisco and HP Aruba and CommScope's Ruckus, all these folks have these NAS offerings. But I think that this is aligning with what we're talking about here. It's fueling, I would say, more interest in that use case, and I anticipate that we'll see more adoption of this approach to solve some of these problems that we're talking about. Over to you, Rocky.
I was going to go back to, again, the user experience piece and having that end to end visibility. You look at a large enterprise and there's the corporate coat of arms. Am I in frame? Where it's your fault. No, it's your fault. And you've got a switching team, you've got a DHCP team, you've got a DNS team, you've got a WAN team. And, you know, there can be finger pointing. Sometimes everyone's not holding hands and singing kumbaya. And you know, for the wireless professional, because we get the blame 9 of 10 times, having that instrumentation in the network, being able to see it from client to endpoint, and being able to find those bottlenecks is absolutely critical today. It's the only way that you're going to be able to suss out in these more and more complex networks exactly where is that bottleneck, where are the issues. So, especially in the enterprise and especially for mean time to innocence, or, you know, to be nice, to find the issue and work as a team and be able to fix it. So, I think it's pretty mission critical to have that view at this point.
And some of the new technologies that they're bringing to bear with not just the artificial intelligence collecting that data, but the ability to have synthetic testing that your infrastructure can switch roles temporarily and become a client and join and act like a device, collect data and report that proactively. So you don't have to wait until the end user's device fails. You have a built-in system that will test that. Or in the case of some of the NAS providers, they have a digital twin, a full copy in digital form of the entire infrastructure that they can run tests against and solve the problems before they happen. So I like the proactiveness that's coming. And yet with all of this, we've been looking at RRM, the radio resource management, trying to solve the RF issues for 20 plus years now. And it still has issues. So this is an ongoing problem, but it's nice to see that they're pulling all the pieces together. It's not just an RF issue. It's not just a DHCP issue. That they have the ability to see in real time what's going on in the entire network.
And RRM being broken has a title, Keith. It's job security for us, right? Uh, like, keep it broken. I love being a wireless guy, but in truth, that complexity I don't think is really understood even within IT organizations end to end. That radio frequency is actually really difficult. It's only about 20% physics and the rest is black magic, right? So you've got a lot of moving parts that people just don't understand outside of the wireless community. So having that instrumentation helps with broken RRM. Yeah, sometimes it's our fault. Sometimes the baby's ugly, right? So it's important to be able to suss all of those individual pieces out and to absolutely verifiably be able to say, hey, we found a bug in the RRM. And I think there's a key too that there's not just the infrastructure vendors, there are overlay networks. There are client-based solutions that give an even deeper view that can sit in the background of a client and run synthetic transactions. Or you have something third party that sits and runs the synthetic transactions. And I think those are key force multipliers in the enterprise.
And those features that you just mentioned can be automatic. That when things are happening, that they're actually just doing it without any IT person's involvement. It's just there. And some of the new features that I really like in this age of AI and RRM is that some vendors make a change to an RRM algorithm, implement it, and the value of whether or not it was successful is automatically calculated based on clients. Did the clients see an improvement? And if they did, that was a good choice. If not, revert back to what we had before without any end user involvement. No IT stuff has to be involved. And then it's a self learning process.
And you took the words out of my mouth, Keith. What is going on that can help improve, these challenges? And automation, I see, is making more progress. And it's also not only specific to, the Wi-Fi implementation, but I'm seeing, the at the CTO level or the CIO level, the prerogative to implement automation across, again, not just the Wi-Fi and mobility network, but across the entire network. And that is, I think, re invigorating, for example, intent-based networking principles, but also more attention as to how can capabilities like event-driven automation can again complement and reinforce that network-wide visibility and observability that folks like Cisco and HPE and Juniper are all prioritizing in terms of why go with them in terms of the Wi-Fi network. So I find it encouraging. I think it's something that is bearing fruit, but also it's showing that okay, we have to walk away from some of the silos in this case that have been a barrier for getting more intelligence about what's going on with the Wi-Fi part of the network.
One thing that I want to bring up here, because we've talked a lot about infrastructure, we've talked a lot about making sure that this, experience looks like this for these users, and your use of speedtest.net is like the ultimate, arbiter of how quick a connection is probably inaccurate. I would go one step further though in saying that the way that most people interact now with the internet has nothing to do with raw speed. In fact, it's usually done through some kind of an application, whether it's logging into salesforce.com online or firing up their favorite mail app or streaming through Netflix. And when you introduce that kind of barrier, you run into other problems. A good example is Netflix, right? The speed of Netflix is impacted by your connection, whether you're using a gigabit wired connection or you're using a Wi-Fi 7 wireless connection. But what really impacts it is latency in the network connection. Is the movie that you're looking for preloaded into a content network that is easy to fetch? There are things outside of the user experience that aren't printed on the back of the box that we have to worry about. And that's one of the things. A recent article that I posted on techstrong.it talked about user experience monitoring, which is one of the next big phases that we've been hearing about from Wi-Fi companies, where they're saying, we need to look at more than just the raw numbers in the connection. We need to look at things like retries. We need to look at things like, jitter in the connection. So, are we kind of hamstringing ourselves by focusing too much on that one number without giving our users that holistic expectation? Or do the users even care at this point?
I I think it's the former. It's absolutely, the speedtest.net example is how the end user sees the network, right? If Outlook is slow, if Salesforce is slow, I'm going to go to speedtest.net, and they're getting that much of the picture of what's actually happening. So and they're making assumptions based on that. And I don't know that you can educate, again, a campus of 50,000 people, but you end up with 50,000 wireless engineers, right? Everyone's going to tell you what's wrong with your Wi Fi. The signal's bad, blah, blah, blah. And to be able to go into a dashboard or, to the points earlier, have AI pop up and say, you've got a crappy connection here. Or to be able to go in and pull a report and say, this was a great connection, but high latency, a lot of jitter in getting to Salesforce that day. To your point, Tom.
Luckily, though, the vendors know this too, and so the vendors, whether it be HP or Juniper or Cisco, they're all working towards that holistic view. Um, but the whole idea that it's about speed has been a fallacy for a very long time, and yet we still revert back to that because it's a simple, easy little number. One example I can give is at a airport, there were some people who wanted to download movies, and that's what you get off a plane. You want to download a movie to go to the next site, yeah. Uh, and the airport authority wanted to throttle their connection because it's not fair. One person's taking too much of the bandwidth, and after multiple cycles of testing, it was stop with the bandwidth. Just give them everything they want. And when they ran the data, they found that if you throttle, it actually chews up more airtime, and it's the one thing in Wi-Fi we have the least of is airtime, and you used more of it by putting a bandwidth throttle on. Just let them get as fast as they want. If they can download a movie in 3 seconds, they get off the network and give you back your Wi-Fi, give you back your airtime. So I think we need to be looking at a bigger model. It's not just the number. It's how did that number affect the actual end user experience? In an airport, it is give it to them as fast as they can take it and they'll get off your network. In hotels, it's something different. So in each environment, we need to understand how the technology works, but also how to fix it in those situations. And it's just comforting me to know to see the vendors are out there addressing this specific issue and they're looking at each of the parts and how to tune them a little better. Specifically for Zoom calls, uh, WebEx, Teams, whatever, that's the focus of how do we make those go as fast as possible.
To Keith's point, I think what is the good news is like for all of Wi-Fi's challenges, the market is going to continue to grow significantly. And I think we understand, some of the reasons why. It's the ease of installation and relative cost compared to some alternatives out there. And I think we're seeing that, with private networks. Yes, they have a presence. They're adding, more organizations, but usually they are being implemented in coordination with the Wi-Fi implementation that already exists. So it's not like, okay, private networks are going to replace Wi-Fi, because Wi-Fi is well understood. It's the devil that is known, so to speak. And if anything, most cases, something like a private network implementation will be a complement to it. And I think Wi-Fi just has more potential out there because, circling back, to the Congress, is that I saw a couple of important takeaways about, hey, can Wi-Fi Halo be something that will make a difference for scaling these billions of IoT connections out there, and do it in just that, in an affordable and secure way. And I think that's something that's important because with say a Halo, you can actually go up to 1.3 kilometers now in open environments. And so I think that's something that will be a factor in terms of, okay, IoT connections don't have these performance demands they have for high bandwidth intensive applications, like Netflix at the home, but certainly workloads at the enterprise environment. And so being able to support 78 kilobits, or at the very top level 150 megabits, well, that's something that I think is driving Wi-Fi's I would say not just capabilities, but also favorability, in terms of why it's just going to get more and more consideration and implementation out there in the ecosystem.
As you can see, there's more that goes into speed than just a number. It's the complex interaction of the technology that lies underneath. And no user is ever going to be truly happy with everything unless it's instantaneous. What you have to do as an IT professional is create a balancing act. You need to invest your money wisely to provide the most utility for your users that you can, while also setting expectations that you're accessing resources that are not directly on your computer. So you're going to have to expect a little bit of delay. Now, the thing you have to understand about that is that no matter what you tell them and no matter how you try to convince them, they're still going to complain that it's too slow. So maybe you can convince them that they can upgrade out of their budget instead of yours. That will just about do it for this episode of the Tech Field Day podcast. I'd like to take a moment for our guests to kind of give you an idea of where to find them if you want to learn more about subjects like these and the other things that they talk about. Keith, where can people go to learn more about your writings?
My website is wlampros.com, and on the other social media, I'm Keith R. Parson.
I'm at Bionic Rocky on all of the social stuff, and bionicrocky.com.
Thank you, Tom. Naturally, there's LinkedIn under my namesake, Ron Westfall. In addition, on X, I can be found at R Westfall DX, and Futurum Group. Please visit the website, futurumgroup.com. Not only does it include the most valuable Tech Field Day content, but also our Futurum research and Futurum intelligence content, which includes, for example, AI data sets, etc. So that's where I can be found.
We want to thank each and every one of you for listening to this episode of the Tech Field Day podcast. If you enjoyed this discussion, please make sure that you subscribe on YouTube or use your favorite podcast application so you don't miss an episode. And consider giving us a rating and a review, because that really helps people as they're searching out new podcasts to listen to. This podcast was brought to you by the Tech Field Day Group, which is a home of IT experts from across the enterprise, which is a part of the Futurum Group. For upcoming events and episodes, please make sure you check out techfieldday.com/podcast or view us on TechStrong TV. Thanks for listening, and we'll be back with another great episode next week.